A few pages further along in the cosmic ledger, the James Webb Space Telescope opens a window to the JADE's GSZ 140 galaxy, a fiercely luminous titan from an epoch less than 300 million years after the Big Bang. This miniature colossus, compact yet heavy with 500 million solar masses, glows with the warmth of furious star formation. What ripples through theory is the detection of oxygen in this primordial world. Oxygen, the product of previous stellar generations, suggests that this galaxy matured chemically at an almost unimaginable pace. To find elemental oxygen so soon after the dawn of time reveals a furnace of creation that was not only blazing, but startlingly efficient, transforming raw hydrogen into complex elements with disquieting rapidity. Shifting focus, the telescope turns toward a brown dwarf, an object often dismissed as a failed star, and uncovers something astonishing. Methane emissions and probable aurorae dance across its atmosphere, a light show that hints at the presence of an unseen partner. A hidden exomoon may be orbiting this substellar body, stirring its magnetic fields into spectral brilliance. The idea that a silent, invisible moon could betray itself through auroral glow reminds us how often cosmic phenomena hide just behind apparent emptiness. Elsewhere, Webb captures 14 Hercules C, a cold giant world gripped in an orbital struggle. It loops through a tilted, chaotic path that defies the smooth elegance of circular orbits. Such instability points to a violent past. Perhaps a companion star or a rogue interloper tugged it off course, leaving the planet spiraling on an uncertain trajectory. It is a portrait of cosmic turbulence, a reminder that planetary systems, even those that appear stable, are shaped by unseen forces. But most unsettling of all is Webb's discovery of planetary suicide. A Jupiter-sized world is spiraling inward to be consumed by a star that is still on the main sequence, still young and burning bright. The notion that a fully formed planet can be lost to its parent star, drawn in slowly by tidal forces, overturns the comforting illusion of planetary permanence. Far from being eternal companions, planets may be mortal after all, doomed to vanish silently before their suns even age. Each of these revelations, a hunted exomoon, the swift chemical maturity of ancient galaxies, the chaos of unstable orbits, the demise of planets, threads together a cosmic narrative that is more unsettling than reassuring. The universe emerges not as a silent void, but as a restless stage of relentless transformation. Objects are born, transfigured, and erased with little warning. What once seemed a predictable clockwork reveals itself to be a symphony of unpredictable cadences. Galaxies evolve with startling speed, planets stumble into chaos or spiral toward their graves, and hidden companions reveal themselves only through ethereal whispers of light. Webb forces us to rethink cosmic timelines. That galaxies like JADE's GSZ 140 could already host oxygen implies stellar generations had already risen and died within mere hundreds of millions of years. That exomoons and solitary worlds can betray their presence only through spectral signs challenges the way we search for distant systems. That a planet can vanish into its star expands the risks beyond the catastrophes we usually imagine. These findings don't just update our astronomical textbooks, they rewrite them. Models of planetary dynamics must now account for deaths by orbital decay, not just collisions or stellar expansion. Theories of galaxy formation must recognize how quickly chemistry matured, suggesting the conditions for life may have appeared faster than we ever dared expect. Strategies to find exoplanets must adapt, listening for auroral whispers or peering beneath a star's glare. At the human level, the weight of this is profound. Each faint signal, whether from a ghostly galaxy or a doomed planet, carries the memory of events billions of years old. Light that began its journey near the dawn of time now reaches us, bringing secrets of creation and destruction. The knowledge that a planet can vanish without a final blaze, or that chemistry could bloom so quickly, paints a universe that is capricious, volatile, and breathtaking. This forms a new cosmic lexicon. We move from imagining a universe of slow growth to one capable of racing through entire epochs. From stable planetary systems to worlds in quiet chaos. From inert celestial bodies to hidden auroral dancers. From gradual chemical evolution to instant complexity. The cosmos is alive, turbulent, and surprising, often terrifying in that sublime way only vast emptiness can be. In this light, the James Webb Space Telescope is not a passive observer but a storyteller. It reveals fragments of a reality that refuses to bow to expectation, compelling us to face truths that are strange, unstoppable, and beautiful. In those truths, we glimpse our own fragility. Earth appears more rare, more precarious, a delicate refuge shaped by the same forces that elsewhere consume worlds or ignite galaxies. The universe is indifferent, capable of forging complexity within moments and erasing planets without warning. And in that indifference lies both awe and unease. Stepping back, Webb emerges not as just a telescope but as a herald of cosmic disclosure. It pulls back the veils and forces us to stare into mysteries that defy explanation yet expand our understanding of how extraordinary our place truly is. As it continues to peer outward, one question lingers, not simply what it will see next, but how we will adapt when the universe refuses to conform to our expectations. The first images released by the James Webb Space Telescope have electrified the world of astronomy. For the first time, light from the dawn of time has reached us with such clarity, revealing secrets that challenge everything we thought we understood about the universe's earliest years. Among the most breathtaking discoveries is a tiny, ancient red galaxy named Kuiper's LRDZ9, whose light has traveled for more than 13 billion years to arrive here. Nestled within it is a black hole of staggering proportions, some 38 million times the mass of our Sun. This cosmic giant formed when the universe was less than 500 million years old, raising profound questions about how such monsters could have grown so massive so quickly. Its existence upends conventional models that suggest black holes grow slowly from the collapsed remnants of early stars. Instead, this discovery hints that some black holes may have formed directly as heavy seeds or through violent, accelerated processes in the turbulent conditions of the early cosmos. The implications stretch far beyond a single galaxy. If black holes of such immense size already existed at this stage, then galaxies must have grown and evolved at a breakneck pace. The early universe was not the calm, steady environment many imagined, but rather a chaotic, energetic forge of creation. Gas, dust, and radiation swirled together in furious cycles, collapsing into stars, galaxies, and black holes far faster than expected. This discovery forces astronomers to rethink not just black hole formation, but the timeline of cosmic dawn itself. Theories like hierarchical structure formation, which describe the universe as building slowly from small clumps to larger systems, may need to be reimagined to include bursts of furious collapse and growth. The search now intensifies. Astronomers will comb through Webb's data to uncover more galaxies like Kuiper's LRDZ9. Each little red dot could be hiding similarly ancient and massive black holes, revealing a population of titans that shaped the cosmos from its infancy. If these objects are common, they may have been key architects of the universe, influencing the growth of galaxies through their immense gravitational pull and by blasting radiation and winds that altered star formation. Such findings would fundamentally shift our understanding of cosmic history, pointing to an early universe where colossal structures rose swiftly and aggressively. The discoveries do not end there. Webb's gaze has also revealed MOM Z14, a galaxy shining brightly from 13.5 billion light-years away. It emerged when the universe was only about 280 million years old, yet it burns with intense star formation, flooding space with ionizing light that helped clear away the primordial fog of hydrogen. This single galaxy suggests the reionization era. The time when the first stars and galaxies transformed the universe was not a slow, steady process but an explosive phase of furious creation. Then comes Julong, a grand design spiral galaxy with elegant arms and a central bulge, seen just 1.2 billion years after the Big Bang. Its existence proves that spiral structures, thought to form only later in cosmic history, appeared astonishingly early. In contrast, the Infinity Galaxy shows the chaos of collision, two galaxies merging in a shape resembling the infinity symbol. At its heart, a massive black hole has formed not in a nucleus but between the colliding cores, suggesting that in turbulent conditions, black holes can bypass traditional pathways and collapse directly from gas clouds. These discoveries highlight that galaxy and black hole formation was not uniform but diverse and unpredictable. Webb's power extends closer to home as well. In the HD 181327 system, icy debris belts have been spotted, providing clues about how planetary systems develop. In another astonishing find, evidence emerged of a giant planet spiraling into its star. Not at the end of the star's life but while it was still burning steadily, a dramatic act of planetary suicide. These glimpses remind us that planetary systems are far more unstable and dynamic than once believed. Some planets hide in dust clouds, others form in unexpected ways, and some are doomed to destruction. The telescope has also pushed the limits of cosmic archaeology, peering deep into the Hubble ultra-deep field and finding thousands of new galaxies hidden within. Each one is a relic from the first billion years of existence, expanding our understanding of how crowded and active the early universe truly was. Webb's discoveries together form a narrative of a cosmos far more violent, fast-paced, and astonishing than we ever imagined. And then there is Uncover Z13, one of the oldest galaxies ever detected, its faint light bent by the gravity of a massive cluster to reach us. This spectral remnant, born just 350 million years after the Big Bang, challenges all models that assumed galaxies needed much more time to assemble. Its existence is a stark reminder that creation was faster, harsher, and more unforgiving than previously thought. Each new revelation forces astronomers to rewrite the story of cosmic evolution. Black holes are no longer patient giants but rapid architects of galactic growth. Galaxies did not form slowly in isolation but bloomed in chaotic, overlapping bursts. Planetary systems are not always stable havens but precarious, shifting arrangements. The James Webb Space Telescope is dismantling the vision of a calm, clockwork universe and replacing it with one of violence, urgency, and creativity. What emerges is not just a new understanding of astronomy but a profound shift in perspective. The universe is not a distant and orderly machine, slowly ticking forward. It is a roaring forge of creation and destruction, where black holes grow like wildfires, galaxies collide and reshape themselves, and planets are born and consumed in endless cycles. Webb's discoveries remind us that the cosmos is alive with energy, drama, and mystery. And with every image, every spectrum, every faint flicker of ancient light, humanity steps deeper into its own beginnings, rewriting the story of creation itself.